Four letters are to be chosen from the letters in the word facetious. In how many ways can you choose four letters? Well, we can see there's 9 letters here and they're all different. And we're just choosing 4 letters. We're not arranging them in any way. So that's just a 9 choose 4. And if we evaluate that, that's 126. How many sets of letters contain at least one vowel? Well, we can look at the case of one vowel, 2 vowels. How many vowels do we have? 1, 2, 3, 4, 5. So we could have up to 4 vowels. But that's a complicated way of doing it. So let's look at having no vowels at all. So there's actually only 4 consonants. So 4C4 is equal to 1. And that's the number of ways that we have no vowels. This was the total number of ways, so we just do 126 take away 1, giving us 125. How many sets of 5 letters can be chosen from the word facetious, which are also sets of the word factorize? So how many common letters do we have here? So the F is in common. The A is in common. The C is in common. There's an E in common. There's a T, an O, an I, but the U isn't in common, but the S is. So that's 1, 2, 3, 4, 5, 6, 7, 8 common letters. And we're choosing 5 letters from those, and that's 56. The letters are now going to be arranged to form different words. From the letters in the word facetious, how many different 5-letter words can be formed? So we're arranging things now, and we could use the box method or a permutation for this first one. So 9 choices for the first one, then 8, then 7, then 6, then 5. And if we multiply that, that's 15,120. One of these 5-letter words is chosen at random. How many of them contain both the letters C and E, but with the C and E separated by exactly 1 letter? So what we could have is the C in here, so that's just 1 choice. Then the E here, so they're separated by 1 letter. Then there's 7 choices that can go here because we've already taken the C and the E from the 9. 6 and then 5. So there's 210 ways there. Now what else could we have? We could have 7 choices here, then the C, then 6 choices, then the E, and then 5. So that's another 210. Or we could have 7 choices, then 6 choices, then the C, then 5 choices, then the E, which is 210. So altogether, those are 630. But then we can swap the C and the E in each case. So 630 times 2 gives us 1,260. Both the letters C and E, but with the C and E separated by at least 1 letter. So that's 1 or more. So we've already got the answer to 1 from up here. So we could separate them by 2. So that would give me C, 7 choices, 6 choices, E, 5 choices, and that gives me 210 as well. Or we could have 7 choices, the C, 6 choices, 5 choices, and the E, so that's 210. So that's 420, which we need to multiply by 2 because we can swap the C and the E. So that gives me 840. And then we can look at separated by 3 letters. So put the C here, 765, put the E here. That's 210, again times 2, because we can swap the C and the E, giving me 420. So we need the 1260, add 840, add 420, giving me 2520.